Right guys, let's have a look at this then. The formula, as I said, I forgot to write it down. Let's just put it down here. Dy du times du dx. There's our formula that we're going to use for these methods. Okay, so we need to look for something then. Well, immediately what stands out to me is if you look at this section here, you've got a bracket, something. This would, if I made that the something, this would be log of something cubed. Now if I go to my table, I haven't got log of something cubed, have I? I've only got log x. So can I make log of something cubed resemble so many lots of this? Well, I can, if we remember that we can use this rule here from logarithms. Remember? The object to a power, this little chappy swings down to ground level, and log na of b equals b log a. Alright? So why don't we just tidy this up? We need to tidy it up just slightly before we do the differentiation and the substitution in particular. So let's just use that property of logarithms then. It's log of an object to a power. This little chappy swings down to ground level, 3 ln 3x minus 1. Now we can try something, can't we? We can say let u equal something, 3x minus 1. There we go. Let's see what that leads to then, shall we? See if we can get an answer from that. So if that were the case then, y would equal 3 ln of the something, which is u. Agreed? 3 log of the something. 3 log u, because the something is 3x minus 1. Now everything looks fine because this is on our table. If we go back to the little bit of bump, we can see that 3 lots of these differentiates to 3 lots of those. 3 log u, if you look at that in your mind's eye in the context of the symbol u rather than x, then 3 lots of log u will go to 3 lots of 1 over u. Yeah? So let's go back then and let's just do it. So du dx then equals, well, that will differentiate to 3 because you differentiate with respect to x as usual. And then dy du, as we said, translate that table in your mind's eye into, or in terms of the symbol u, you get 3 lots of, what does log u differentiate to? 1 over u. Here's your answer. So then dy dx then, dy du dx, dy du is that times that. So I'm going to write this one first because it's that times that. It doesn't matter which way you write it. 3 times 3 times 1 over u. 9 over u. So dy dx then at the very end you put back in what substitution you needed to make. So it would be 9 over 3x minus 1. That's it. That's all there is to these problems. They're all the same in terms of their form and structure. And this is the method. Yeah? So we should be able to rattle these off quite simply now. Yeah? Just a tiny bit of tidying up needed here and there. Okie dokie. Let's go on to the next one then.